Hello everyone. Last video we have discussed about uniformly accelerated motion when the velocity of the object is increasing. Here when time was zero, velocity was zero. But as the time is increasing, the velocity of the object it is increasing. Here acceleration is constant. But for this graph, what we have considered is velocity is increasing. What is uniformly accelerated motion? Object travels in a straight line and its velocity is increases or decreases. This is very important. Velocity, it can either increase or it can decrease by equal amount in equal interval of a time. Then the acceleration of the object is said to be uniform. This is also uniform motion, but for this uniform motion, the velocity is increasing and the change in the velocity or whatever increase happened for the velocity for the corresponding time intervals, that increase in velocity, that magnitude with respect to time, it is constant, or dv by dt ratio here, it is positive. Here the slope of the graph is positive, right? Because here we are saying velocity is increasing. Now we will consider one case where the slope of this line is not positive, the slope is negative. What does it mean? Here we have considered the velocity is increasing. Now we will consider velocity is decreasing. Or simply for this graph, what is the consideration? When time is zero, velocity is zero. Or initial velocity of the object is zero for this case. But for this case, what we are saying, that object has some initial velocity. Somewhere here that initial velocity, it be here that initial velocity, and after as the time has progressed, the velocity is decreased like this. Here velocity is increased, but here from that initial velocity, the velocity decreased, and somewhere at this time, the velocity has become zero. For this case, velocity is zero when time is zero. It is increasing. Maybe somewhere for this point, the velocity is maximum. For this point, velocity is maximum corresponding to this time. But in this case, here it has some initial velocity, u maybe, and then that velocity has decreased, and particular at this point it has reached and it has become zero. For this graph also, for understanding, we have divided the time intervals, and duration of the time interval we have taken as a dt. So 1, 2, 3, 4, 5 intervals we have considered. Again, for any time interval, you just observe the change in velocity or dv. So this dv, this dv, this dv, this dv for any time interval. Suppose this time interval, if I say it is time interval 1, time interval 2, time interval 3, time interval 4, time interval 5. For any time interval dt, the decrease in velocity. Here I have said increase in velocity dv. Here I have to say decrease in velocity dv. Value of that dv or the magnitude of that dv, it remains constant. Or if I take the ratio dv divided by dt for any time interval, in this case, that ratio is constant, or here the slope of this line is constant. This line is nothing but acceleration only, but this acceleration is in negative direction. This acceleration is in a positive direction, right? This is also uniform acceleration. This is also uniform acceleration, but here it has a positive sense and here it has a negative sense, because here velocity is decreasing and here velocity is increasing. So both are uniform motions only. So what is the example of this? Is a stone thrown in upward direction until the maximum height. This example in detail we will discuss in the next video. But the thing is, for this case, velocity is increasing. For this case, velocity is decreasing. But as we have said, as per the definition of uniformly accelerated motion, the increase in velocity or decrease in velocity, magnitude of that, it is equal for any time interval, or it is in equal interval of a time. So such kind of motion is called as a uniformly accelerated motion. Thank you.